Hey folks, looks like Suke is here.
Hey, Yogesh, how are you?
How are you,
Happy New
man?
Year.
Happy New Year. Good to see you here.
Yep, it's I think good to be back in the Raz world.
Nice. So you are with who now? I'm sorry, I forgot.
I just joined Meta
Oh,
last month. So,
nice. Very nice. So you work with Anil?
yeah. I think um it'll be like the old times.
It's great. Good to have you.
Yeah, good to work with you again as well and see some familiar faces. Always makes it easier, I think.
Yeah.
Happy New Year.
Hey
Happy
Drew,
New Year.
Happy New Year to you too. We missed you last week.
Oh, yeah, I was out, so did much happen?
No, it was very skinny. Actually, I should have polled people if they could meet. So it was not much, not, I think like 4 or 5 people joined. So we just canceled it. Kind of dropped off quickly. I just told everyone that the CPAL doc is there. If anyone wants to take a look at it. Yeah,
Sounds
that's
good.
all really good. Yeah.
Well, and I guess I'm also just have to say I'm in shock about Mark.
Yeah, that was a yeah big surprise. Very sad to hear that.
Likewise.
Yeah, for those of you that don't know, Mark Fletcher passed away and over the holidays, so from cancer, and I don't know. He's a guy that I had I've had like engineering months of arguments with Mark over the years. But we liked each other. We would just go hammer and tongs debating stuff really hard. And we get frustrated, but we respected each other. And you had to listen to him because he had the experience. He had the scars to, and if something was bugging him, I just have to go back and go, okay, there's some not understanding. There's some problem that he had, and once you find it out, you're like, oh yeah, I better get on that. I better account for that. So it's a pretty big loss, and we're really going to miss him, I think.
Yeah.
Yeah, I
Uh,
can say a few words. My introduction into the RAS world, like maybe a decade or maybe more than a decade ago, was really kind of, Mark uh, in HPE and I was in Intel. And I mean, if it's true, you have educated me a lot also. So Mark definitely, I will never forget the kind of passion he had to challenge us at Intel and also share the pain points and whosoever could listen in Intel. And I was fortunate enough to listen to that. And that helped myself and Intel to enhance so many features in Intel. I'm sure same thing with AMD and other vendors also. So his value in terms of driving the industry, the ecosystem, to solve some of these difficult RAS problems is unparalleled.
So anyway, yeah, it's pretty sad, but and I think the world's lost an important RAS expert. So.
Right. One thing I always tell whenever we meet together, among all these people, us here, we have maybe more than 100 years of experience in RAS, and this is the only body of RAS
Yeah.
expertise. out there in the whole entire industry.
Yeah.
And
At this kind of scale, I think, yeah, I agree.
yeah.
I agree. Okay.
Anybody
Well,
else want to share anything about experience with Mark?
Yeah, I'd agree with you, Anil. And you're talking of the days when RAS was not such a big buzzword, but definitely in Mark, uh, vendors like Intel had a very passionate partner, and that is a big void. We don't know. It's yeah, his passion, his attention to details, his drive, all of that was commendable, and that's not something. That combination is something, not something that comes around, often. So definitely something that will be missed for ages to come.
yeah.
Yeah, I would also say the same actually, since in last 3 years or so, the interactions that I have had with Mark, they were really like educating for me. Like I started really getting interested in the problems that he's mentioning. Interested in RAS really deeper is when he started mentioning like depth of the problems, right? Like and how John said that everything is a fatal flaw, right? Like for him, it used to be everything was a fatal flaw. And then even though we consider it as a small thing, he would treat it as a big thing. But that did make us go deeper and look into the root cause, right? And like you kind of build up upon that. So yeah, I worked with him the first time. He pushed it so hard that I was like, oh, literally in 2 months I had to come up with a solution. That is how I first interacted with him. And but it happened, and he was very happy that we made it work within a time. And after that, it was, even though he was always demanding, I always listened to him, like to understand what the problem is. So learned a lot from him. Yeah.
Yeah. Well, we'll miss him, that's for sure. It looks like we have some new people on the call, by the way. Or maybe just new conference room names.
New to call, but not new name to folks from Intel is Suke, who's with Anil now.
Okay.
Suke, you
Hey
want to
everyone.
introduce yourselves?
Yeah,
Yeah, Suke, you want to introduce yourself?
sure. Yeah, happy to see some familiar faces too. And I think actually, Shubhada, I remember working with you in the manageability days in my first kind of job at Intel. So been at Intel for 13 years, was working in the manageability space, then moved into RAS, where had a lot of fun with Anil and Yogesh, some other folks too, as well, and moved into HSI High Speed IO in the last couple of years, and happy to be back in the RAS world now at Meta. So, a bit about my background.
Awesome. Welcome.
Yeah, happy to have you in
Good to see you again, Drew.
There are a few other.
Although I think there's Lavanya. Lavanya, maybe, I'm sorry if I should know you.
Yeah, you pronounced it right. Hi, everyone. So I'm Lavanya. I have done my bachelor's in electrical and have 6+ years of experience in hardware engineering. But I come from a different industry, automotive hardware. I just want to explore and contribute my skill set towards the OCP, and that's how I ended up here. It's nice meeting you all. I would like to learn and contribute to OCP and the
Awesome.
projects.
Well, we're thrilled to have you. And Lavanya, are you representing a company, or are you just here personally?
It's a personal contribution. Yeah.
Cool. Okay. Well, welcome. We're really glad to have you and look forward to working with you.
Thank you.
Where,
Thank you too.
where have you worked before, Lamia?
Previously, I worked in Continental Automotive, and it's a German-based company. And now I'm presently working at Pakar Embedded Engineering. Pakar is a trucking company in Pacific Northwest, based out of Seattle.
Nice.
Yeah, Lavanya, I saw Continental at OCP, and I'm thinking Continental Engines, which is an aircraft engine. So I can't afford a house in the Bay Area, so I fly to work and have a Continental engine in my plane. I got really excited, but then I realized, no, it's not the same people.
True. But yeah, I was working in autonomous mobility division. That's where I come from.
Okay,
Yeah.
awesome. Yeah, I think, and it'd be great to have your perspective, because I think that there's some overlap. You know, there's like a different group of people that works on reliability in automotive, and we have a lot to learn from each other. And I've had precious few connections to that group, so it'll be great to have someone with your background.
Yeah, and I do have a good experience in hardware reliability in automotive side, so I just want to bring those skill set here. Yeah.
Sounds great.
Yeah. Thanks to and thanks for all the people.
We
And then,
also have to
oh,
do.
yeah, I was gonna ask. Go ahead, Yogesh. I'm sorry, I didn't mean to step on you.
Yeah. Oh, no. Please go ahead.
Well, Varun, there's, I think Varun, and I'm not.
Varun has been attending for a while, but please go ahead, Victor and Varun. Please introduce yourselves.
Hi, so I'm Varun. I think you might have spoken to my boss at OCP. I work for Chinmay at Intel. So at Intel,
Oh,
I
good,
lead
good. Oh, we're glad to have you. Yeah.
I lead a team that works on telemetry architecture and some of like the standardization for some of the telemetry that we extract from the SoC. And I joined Intel a couple of years back. Prior to that, I used to work at Twitter, where I used to lead their firmware and performance teams for their data center org. So happy to be here.
Yeah, glad to have you. That's exciting. I'm really happy you're here, because we want your help with the RAS API also.
Yeah.
Okay, and sorry, I guess, was there someone else? I'm looking through the names.
Yeah, I don't know if we got to get introduced to Victor Liu. At least I don't remember, and I may be wrong though.
Yeah, this actually, I think I joined probably either third or fourth time already, but I'm not, I'm not a hardware person, so I'm independent, just interested in overall hardware. I'm sure that Vijan has saw me many places, so I'm just here to listen and learn.
Awesome. No, I know you just here personally, or for a company also, or?
I'm independent. Yeah.
I'm sorry?
Yeah. Just myself.
Just yourself? Okay. Well, welcome. Well, we're glad to have you.
All right, thank you.
Okay. So Yogesh, what did you want to do? Do you want me to put up the CPAL proposal, and do we want to work through that any, or what?
Yeah. So let's see. So yeah, we are starting new year. We had some of the things that we kind of left in the middle of the last year. In fact, the in-band document, we have not been able to make a whole lot of progress, and we knew it because Anil had declared that he will be out for some time, and he's the primary driver on that one. So that's something that we need to pick up. And then in the meantime, there was this discussion about the output from the analyzers for RAS actions, and Dixon and Drew further worked on that. And this proposal document is in place, which is taking shape. We need to start talking about that, discuss, and agree or disagree on that. So, Drew, if you want to share that, Anil, is it okay if we go with that first and then pick up maybe our in-band next week, or because I don't know if you have made any changes, progress that you want to discuss, review today on the in-band requirements doc, or should we go ahead and go with the open and introduce people to the CPAL proposal? We call it CPAL. It's kind of maybe a temporary name. It's a common platform action log for error analysis, but no one has really seen that in the current form. So we kind of have to introduce people to that, start the discussion. What do you think, Anil?
Yeah, I think that should be fine. I did notice some edits have been already done in the 1.5 doc of the hardware fault management requirement document. And yeah, I will work on cleaning up more and maybe offline discussions with key folks who volunteer to edit further. And definitely we want to get to some conclusion, like cleaned up version for the final review. So yeah, I think we can defer it for next week. I do want to request one thing, Yogesh, since we are starting the year. I think we should set the sort of agenda or directions. What are the areas we want to focus this year, and some sort of a milestone where what we want to achieve at what point in time.
I think that's a great idea, Neil. And maybe what we could do is look across all the fault management efforts and say, RAS API, FMFM, like what's going on. Remind people. I'm not saying revisit what they're doing, but just say, here's where we are, and here are the pieces. How do they fit together? And then, given that these are all the efforts and pieces that are in play, where are the remaining holes, and what do we need to work on next? But I just want to do it in context of all the efforts, so that we look for the whole, because I don't want to go say, hey, I want to go work on analysis when FMFM's already digging into that.
Yeah, no, I think I would agree with that. I think we are very much an umbrella a group where we started all the other initiatives from, including GPU RAS and fleet memory and interface
RAS
API.
API.
So I think a good exercise for us in the beginning of the year would be to kind of stitch together this big picture, review it, and kind of present it to the hardware management and OCP leadership. That these are all the initiatives, and these are all the different pieces and how they fit together. What's the big picture look like, right? So
And I've been working on some slides to do that internally at Microsoft, but I'd be willing to contribute some to that. And if someone, I don't know who else wants to. I mean, we can do it here. I can bring it here, or if someone wants to work with me offline, and then we come here and refine it. I don't really care, but I'm doing it because I need it myself internally.
Yeah, I presented a version of it in the IEEE RAS Summit. How different pieces are part of the big picture, but of course. That was first cut and needs to be more refined and detailed.
Well, and I think the other thing that I want to do is I want people to understand what a big deal like RISE API is, for instance, because having a standard way of collecting error logs could change everything. So that's part of what I want to do is make sure that I can explain it in a way that executives at our respective companies go, oh, that's what you're doing. I want that, So that's what I'm doing internally. But I'd like to share that because I think we all need to do that to build support.
Yeah, we need to go second click on my document and define what needs to be defined, which aspects of various touch points belong to which specs, and who are the key, what are the key deliverables, who are the owners of those deliverables, what's the mechanism we propose, and what are the compliance documents, requirements, specification, what have you, is produced by OCP, and how it relates to the other outside industry bodies. We need to do all that homework. By the way, sorry, real quick, Vilas, it seems like you're trying to speak. If you are, your voice is not coming through. It's just some kind of noise coming through. So
nope, sorry. I went off mute accidentally.
Oh, okay.
Okay. Welcome. Happy New Year, Vilas.
Yeah, Happy New Year.
Okay.
Maybe one thing I want to kind of just dwell on that is those who are on this call today, right? Again, being the first call of the year, anybody has any suggestion, thoughts, what they expect from this forum? Please share, because this is all collective.
Just had a question on that note. and maybe this is kind of silly, but so ultimately, are we trying to drive some kind of a spec that's going to be like an industry standard for this for RAS API? Just want to hear a little bit more. I think.
I think specs plural, and so RAS API is an effort. It's closed CLA, which means a contributor license agreement, because it's a spec. They are developing a spec, and we have to follow the OCP process. And to protect it, people have to agree to contribute their stuff to the spec. So we're doing it that in that forum. But in this forum, we're building the umbrella, like the RAS API is implementing a section of what we've described here. So this is kind of the umbrella, big picture. And then out of that, we said we need to do better with memory error analysis, the memory fault management. We need to come up with a standard way of collecting errors out of the machine and a standard way of talking to silicon, RAS API. And then there's a GPU effort, and there's data resiliency, which isn't really us, but it relates peripherally to us. And what am I leaving out? There are other efforts. There's some debugging discussions. I mean, there's just little things happening all over the place. So that's what we want to do, is build that big picture and make sure that everyone's aware of everything that's going on.
Okay, thanks. That helps clarify.
And there's one other thing, I guess, Open, I want to mention. And there's no action needed right away, but I was talking to Preeti Chowan. She is the vice president of the IEEE Reliability Society's events or something, events and planning. I can't remember, but she was at the RAS conference, and I think a lot of us signed up for the Reliability Society when we were there. But she wants to have a workshop in April at the IEEE Reliability International Symposium or whatever in Monterey, California. And so she asked if I would work with her. And I told her I'm happy to. I'm working to pitch that to people inside Microsoft, but I'd also like to come here and make sure that you all are plugged into what we're thinking. And if you're interested in participating, make sure that that's open to you.
Drew, this is IRPS that she wants to do that?
Yeah.
Okay.
Thank you. Oh, you sounds like you're familiar.
Yeah, I've given talks there before.
Okay. So yeah, she is. She's asking me to co-chair a workshop with her, and so, but I'd like to do it with you all. I mean, of course, she's asked me to co-chair, so I'll do it. But I want to keep you in the loop and give folks here an opportunity to get involved as desired. Okay, well, I'll let you know as I know more. Very early days on that, but I just was letting you know in case you're interested. Reach out to me, and I will be happy to work with you.
So I'm not. It's okay. I mean, it's okay. Take a look at this this document. It's several layers of really building the body of knowledge. Best practices. Terminology, nomenclature, classification, all of that, sifting into what are the requirements for data center, sifting into what specs and interface definitions we need, what protocols we need, what framework is needed. So all of that is being developed under various. Not everything is a spec. Some are requirements documents. Some are just kind of white paperish level industry alignment, because, like Anil said, this group has who is who of industry RAS, experts. So all of us agree, then, we have pretty good consensus, and those are also documented. So that's kind of part of the requirements document also. But feel free. I mean, you have Anil on your side, so I don't think I need to offer you additional time to go over this, but feel free to reach out. And anyone else also, if you have any other suggestions, feel free to use the groups.io email it broadcast to everyone. We can communicate that way also if you do not want to speak up today.
I'll
And,
always appreciate any kind of help too. So it's thank you, Yogesh. Appreciate that.
Sure. So yeah, I was going to say, if there's nothing else, we're almost at the halfway mark. Drew, shall we let Drew introduce the CPAL document a little bit more? I know, Drew, you have added a lot of things. I was looking at the document. And,
yeah, I've worked on it intermittently. Sure, give me 1 second. I'm grabbing. I'm looking for the tab. Okay. So this came out of 2 conversations with people in this meeting. The first one was with Anil, where we're talking about how do we do something fast, and how do we make quick actions from things in error logs. And the problem is that if the analysis results are always different, like there's not the everyone does it their own way, and there's no consistency. It's really hard to integrate the analyzer, and it's really hard to take action on things. And so, the request was, we know that we want to gather error logs a certain way. We transmit those error logs somehow to something that analyzes them and decides what to do about them. And then, based on what that analyzer decides, we look at it and we say, do we trust the analyzer? Do we trust this particular conclusion? And if we do, then we want to either drive a RAS action back in the machine, like a self-repair action, or turn on a RAS feature, or we drive a repair. And but to do that means that we probably want something standard coming out of those analyzers, and not standard in terms of, we're not trying to restrict the types of RAS actions, and we're not trying to restrict the richness of the analysis. We're just trying to say, can we make some things that come out of the analyzer that are common enough that we always know that they're there? And do we need 10 ways to say replace the part? Or can we just have something that says, when you see this in this output, replace the part? And so I was talking to Vilas about this, and we tossed around several names, but he said, hey, it's kind of like you need a mirror image of the CPER. CPER is the input, and can you name something for the output? And it can even look a little bit like CPER. And because one of the problems I was telling Vilas was, imagine that I have 8 GPUs in a machine, and they're all connected in my dream world by the RAS API. I'm getting error logs from all of them. One of them is having errors, and I need to do, let's say, an HBM row repair. I need to have an analyzer that recognizes that, but the analyzer is going to spit out this message, and somehow I have to associate that message with the correct GPU on that particular machine. And there are 8, so I have 1 in 8 chance of guessing right. The odds aren't great, so I need to match the 2. And so Vilas made the observation that CPER had some standard fields like creator ID, partition ID, and that we probably could figure out how to align a CPER with an endpoint that generated an error log, and maybe we should make it look a little bit like a CPER record. And so that's the genesis of CPAL. And so, Vilas, I don't know if you have anything to add, because I'm running with your idea, but is that a pretty good capture?
Yeah, I think you captured it exactly.
Okay. So I ran with what you proposed, Vilas, but I changed the name a little bit to CPAL, so there was a little bit, but the name that we were using, I can't remember what it was. I think Action Record, CPAR, and CPAR and CPER are too close, but I thought CPAL was a little bit distinct. I don't really care. We can name it whatever we want. But the idea is that, like I said, we associate the error log and the RAS action with the endpoint that sent the error log. So you have errors, you want to take action on the thing that has errors. We also want to make it easier to parse the output. We want to make sure we have common fields where it's appropriate, and we want to make it easy. So if, let's say, Texas Instruments jumps into or maybe Ampere makes an analyzer, some new company comes along, we want it to put out the same fields and be easy to integrate. And I think that we don't need every, if I look at tools that are out there, like Intel Summarizer is super rich. It's amazing what it spits out, and I love it. It's awesome, and it's extremely useful for debugging. So we don't want to limit that, but there are also just a few common fields that we we always want to get. And so, oh, and I'm sorry, I should have been scrolling down. I'll jump to the few fields we want. Here's a kind of a flow of what I was imagining with my GPU example. And I'm showing the RAS API can work in band or out of band. Um, and that you parse the header, you send it to the right analyzer, the analyzer evaluates the accuracy, it applies whatever policies of trust we have for that analyzer and sends an action in my dreams back to the RAS API. And because the CPER contents matches the CPOL, the RAS API just knows where to send it. It goes to the exact right place. So that's an example of using a CPAL to drive a RAS action. And then, here are some things that I was proposing we could drive with CPALs, but or put in CPAL. So name of the failure. We might do a RAS action. It could be that we know there's a it's a CPU and there's some microcode fixed to this particular problem, and so it doesn't hurt to say you should really update your firmware. And then one thing we'll want is a chipset ID of the FRU that had the error, and somehow we have to be able to map the identity of that thing from the chipset's perspective to whatever's labeled on the system. And I talk about that more later. Go ahead,
I have a question.
Yeah, please.
Hi, this is Meeta. So I haven't looked through this document, so maybe you already have it somewhere, but
oh, I'm sorry, Meeta. You're Shibata had her hand raised, but go ahead. I didn't realize you were whiskey sour.
Okay. So is the CPAL also going to point back to the error record that resulted in it? Because I think that might be useful. You have an action, and knowing which CPER resulted in this action, is that already implicit, or?
The way I would look at it is you could do it for the CPER that broke the camel's back, but imagine we're doing time series analysis. It might be the first time you get a memory error, you say, I've got a memory error. Second time, you go, wait a minute, it's on the same row. And the third time, you go, wait a minute, I've seen row errors on multiple accesses to this row. I'm convinced I had the row error. And so I don't know.
Yeah. I think a simplistic way to do it would be to have a pointer to a linked list of CPERs, right, in the CPAL. And that could be one, that could be more, but it doesn't limit you, right? Like that's just, or it could be zero if there's nothing, whatever, right?
Yeah.
But I think just having something like that would actually be useful.
So the exerciser itself can create logs and messages. I'm not sure why you want to build it into the communication mechanism. Those sort of footprints belong with the analyzer, don't they?
I think the main reason, Gene, would be that in principle, the CPAL then gets divorced from the analyzer. Like as an example, Microsoft has some analyzers, some, I don't know, Drew used Ampere. So Ampere analyzers running in their fleet. That Ampere analyzer spits out a CPAL. Microsoft says, hey, I don't know what to do with this, or there's something weird here. Ampere, go look at this CPAL, right? And like it would be useful for Ampere at that point to have some number of CPERs or whatever, like as a single data structure versus Microsoft having to say, well, these CPERs went into this thing and this came out, like, having to kind of reconstruct that, right?
So,
I think it's that.
So what you put in were just a list of CPER IDs, not the CPERs themselves.
I mean, you could do that. Yeah. It could be a linked list of CPER. It could be, GUIDs that some GUID that matches the CPER, so we can unambiguously, do a join. Sure.
Well, so linked list of CPERs. You mean?
Oh, sorry.
I'm sorry. Let me just linked list of CPERs. You talking about pointers to the actual contents?
Well,
in which system?
Well,
for now,
it's a binary.
For now,
it's a binary output, right?
Yeah.
Go
Let's
ahead.
just say a linked list of CPERs. Now, whether it's a linked list to a GUID or a linked list of like actual like CPER binaries, like let's deal with that later, right? But I think that's the general point is, that'd be useful, right?
Yeah, I mean the CPAL is a data structure, so theoretically, if you really wanted to, you could put the seepers in the data structure. I'm not saying that's the right answer. I'm just saying, it is a possibility.
Hey, Drew, you probably want to write a pointer to the linked list, not a list of seepers in the CPAL. That would be too much.
Well, but what memory space are we linking it to though? See, it has to go in the CPAL.
Yeah, it's not a pointer. There's no world in which it's a pointer, right? It is just embedded in this data structure is another data structure, and that data structure either has a bunch of GUID or a bunch of secret.
There's there's just some other association. We need an address scheme for CPERs, and we either embed them in the CPAL or we have the CPAL refer to them in a way that we can find them unambiguously. And you could say we want to extend the CPER format to have here's this CPER's GUID, and so then all I've got to do is search my pile of CPERs for ones with those GUIDs. We can deal with that a little bit later. But that's the idea. So I follow that. So it's worth additional discussion. But Shibata, you've been so
Yeah, I have a
patient.
comment about that. So
Yeah.
But is that always the case, right? Like you could be monitoring some CPERs and your analysis tool could be deriving some conclusion out of that. Like as you mentioned, like timing analysis, or we could even be feeding it to some AI or machine trained module. And the action really comes out as a result of that analysis, right? And in that case, I mean, which CPER are we acting upon? It may not be, it may be irrelevant, right? I think, is that information truly needed with the action, or can the action be independent, where like all of that data is contained without necessarily addressing the error record itself? Like the data from the error record is extracted and it is with the CPAL, but it doesn't necessarily have to refer to the record, because record could be already removed on the other end, right?
So I think part of the point of providing a linked list is that you can keep it as a null list. Like that's a fine choice for the analyzer, right? I just think it sometimes would be useful to actually have that data in there, right? But if it's all zeros, then okay, it doesn't exist, right? Like we can define the data structure, it doesn't require it, right? It just gives you the option to put it in.
Yeah, I think that's the point. I think I see less value in sending a big bulk of the records sent as an attachment back to the action request. I think if this is coming from data center or hyperscaler infrastructure, maybe it creates some sort of a software record number of what is this, some notion of what is this based on. And that notion could be very proprietary to on what basis this action was taken, and it could have a bunch of CPERs, no CPERs, or just some magical AI decision maker or boss said that kind of thing.
Yeah.
That could all be encapsulated as some reference, which I thought of as a pointer, but that is really all you really need, and we don't need to bulk it up with a lot of records. That's my opinion.
Well, and I guess I want to address, so Charlie and Dean are kind of having a conversation in the comments about this as well. So one thing is the analysis is always kicked off by a CPER, because the only time you can conclude something new is when you have new data, and the CPER is the new data. So there'll be a CPER, and then the question is, how do we account for an error that happens due to multiple faults? And the memory one is a classic example. You get multiple errors, and at some point there's the error that breaks the camel's back. But you were looking at a trend of things, or it could be that you say, well, when I see this timeout and I see this failure, it's a PCI problem. When I see this timeout and this failure, it's something else in the chip wedged failure. And so, but those, because what we're doing is we're giving the analyzer a series of error records, and the analyzer is drawing conclusions, and it knows what records it used to come to those conclusions. I don't care if it's mandatory or optional, but I think there is the the thing here that we're talking about will work. The cross-domain thing I can answer is in that like a silicon analyzer will not know about a power fault or a temperature fault that was monitored by manageability. You know, like something that the BMC knows about, maybe something different than the SOC knows about. But in our analysis framework, the CPU analyzer won't know about that. It'll just go, this was acting flaky. But then I'll also look at another error record and say, and the CPU didn't have good power, so it's no surprise that it was acting flaky. And so when we look at multiple analysis domains, we're going to have to learn to reconcile them. And I think I talk about reconciliation here. If I don't, yeah, I think I did talk a little bit about reconciliation, but I'll work on that some more. I've got
more generally, Drew, right? I mean, all the drawings have the analysis output sent to a policy engine in the data center, right?
Yeah.
And that policy engine can do that kind of reconciliation.
Oh, very, very much. That was
Right.
very
But I just
much
want to be
my
very
intent
clear,
in putting that there.
right?
Yes.
Yeah. So, but that's the intent of all the drawings. That's why they have a policy engine there, right?
Well, it's one of the reasons. Yes.
Sure, one of the reasons.
Yeah, and the other reason is just self-protection. You know, if I were to accidentally, heaven forbid, get an analyzer that said that all my memory was bad, you know, I don't believe it, right? So, and it might happen. You know, there may be some corner case, you know, that happens, and so, you know, the fleet policies reconcile analyzers that disagree. It also rate limits or limits the impact of an analyzer when it's maybe putting out questionable things. And it also gives the fleet owner the ability to evaluate the output of the analyzer on a case-by-case basis. So, you know, I can say, well, I've got some history here. When I get this particular error from the analyzer, I know, at least in my data center, it doesn't appear to be very accurate. So I'm not going to do it until I see it twice.
Yeah. Dean, you made that comment. So I guess, I mean, I know where you're coming from. Maybe I want to give a little bit of level setting context, right? Like all the stuff we're talking about here, like it's not fundamentally changing what is possible. This is kind of how I think about it. It's making it more efficient, right? Because right now you can do all of this stuff, but you effectively have to do it locally on each node all the time independently. And you know, if you're running single computer, that's fine. If you're running a million computers, that's not the most efficient way to do it. You want to do it in the data center, right? And putting the infrastructure in place to, you know, put all that stuff in the data center is the point here, right?
I'm not sure why you're addressing that to me. I agree 100%.
Oh, okay, sorry. Well, it's because you were talking about. Oh, maybe. Oh, you know what? It was Charlie, maybe, that was talking about the cross-domain or cross-error domain.
Right.
So sorry.
Yeah, exactly. And my point actually was that you can have a case where whatever your sensors and BMC are set up to detect power supply issues might not be sensitive enough. Maybe memory is more sensitive. And so your power supply analyzer isn't going to be getting any error data, but your memory is. So at that point, you say, wait a minute, something's going on here under the covers. Now, maybe that takes a human to figure that out now, but ultimately the analyzer will be trained to be able to catch that type of stuff. So
and not only that, Charlie, right? Like when they figure out that that's a problem today, they have to, I mean, you know, effectively go do a firmware update on every node to do this, you know, to say, no, this is really a power supply problem.
Yeah, right.
In this case, they just got to update the analyzer in one spot. Like it's way easier, right?
Yeah.
So, okay.
Yeah, Vilas,
yeah,
agree.
I just wanted to,
100%. I'm behind this all the way. What I was trying to point out, though, is that very rarely does a single error point to a single fault. There could be a single error could be caused by multiple faults. As you collect more errors, you kind of whittle down, well, with these new errors coming in, it's not this. These are the only ones, until you get to a point on the list where you or the analyzer are going to have to make the decision, I've whittled it down enough, I want to take action, versus waiting too long and things crash. You know, so at what point then do you do you kind of decide to pull the trigger? And I think that's where the fleet policy comes in. If the analyzer says, I'm 90% sure this is a row fail, do a hard repair, you might say, well, 90% isn't good enough for a hard repair because I can't undo that. So do a soft repair instead. You know, and then you...
I'd like to give another example related to the one you just gave, but I'd put it this way. So let's say that I have a cloud workload on my machine, like search. And I have a fleet of machines that this is cloud native software that's highly fault tolerant. So if any given machine has a problem and dies, the software runs just fine. I might tune this to act on only the highest confidence things because I don't really care if the machine's crashed. I have a workload that just tolerates it imminently. But now,
okay, yeah.
let's say that I have a GPU training cluster where I have $50,000 GPUs and I have about 20,000 of them all in one giant cluster working. And when any one of them crashes, I got problems. What I might do is I might act on some of the lower confidence things to drive RAS features to try to keep my cluster up. And so that's another area where the fleet policies come into play. Is it depends on the workload. It could even be the same stinking machine, just a different workload.
Interesting. You've kind of pointed out an escalation Cisco has been dealing with another customer, which is exactly that case.
You know why I came up with it is because we've all got the scars on our back. Yeah.
Yeah. But that also raises an interesting question I've got in terms of how can we kind of uncouple or at least recognize, hey, these are hardware or component faults versus no, this is a software bug. Because a lot of the problems I look at, memory problems, ultimately turn out to be a software bug. Something like we didn't initialize the memory correctly, but we fight these battles of going back and forth with our component suppliers saying, have you run this test, have you run that? And it's like, oops, sorry, never mind. Your DRAM is okay. We just didn't initialize it correctly.
Yeah, I don't know what to do there.
Yeah, but it's an important problem for us to kind of understand. And a lot of the field escalations I look at, they're not component issues, they're software issues.
Okay. Well, I think that's actually a difference between hyperscalers and your situation. It makes a lot of sense because when you control the software running, you know, you can go, wait, I just rolled out this new software and suddenly had a bunch of failures. I suspect the BIOS. It's this new BIOS, you know?
Yeah.
So Charlie, the two obvious things that jump to my mind for that case is doing parameter checking, right? Which means you know the right values and you just check and see if you have them. And the other is running a diagnostic, which I don't normally love, but where you modify, you shmoo or whatever the values and see if something changes. But the case that case is probably a notoriously hard to debug case, isn't it? Kind of like timeouts.
Welcome to my world.
Yeah, no, I've been there before. I got the same scars as Drew.
Yeah.
But I'm not sure. I'm not sure that this group can answer that.
No, that's fine.
Well, if it was a rhetorical question.
Yeah. Yeah, I thought I'd throw it out there and see if somebody had a light bulb went off and said, "Oh yeah, this is we can incorporate this. This is fits under the umbrella."
The light bulb is already blinking in my eyes, and yes, we can do that.
Okay, yeah. You got your hand up, Neil. What do you go for it?
Well, I just wanted to kind of introduce Drew toward the end of this chapter. I mean, this document. I was thinking as I was listening, right? What are the kind of actions that can be taken, and can we kind of define the format of those actions so that they look similar regardless of what kind of machine it is, which vendor is providing the logs, and an analyzer, whichever the vendor's analyzer is being used. The output should look very similar so that the rest of our tooling infrastructure can rely on that.
Yeah.
Well, here's
I
what
think that, hold on. So I think that's explicitly the intent, Anil, right?
Yeah, if you scroll down, I started writing down, and please feel free to short me down right there. Or
but can I want to talk about one thing theoretically, and then let's go to your thing. I want to come back to this drawing. So
there's one thing missing in this drawing, Drew, before you say more. The green arrow that you're feeding back, from the rightmost box, right? I think there is another arrow required, which goes all the way to the right, repair action.
No, okay. No. Okay, this is really good. You don't understand the drawing. I'll explain.
Okay.
So when you generate the CPAL, okay, CPAL is green, and the CPAL does incorporate the repair action. And let's talk about the range of repair actions. We might have a JetX spec defined one, like post-package repair, that it's pretty common, should be pretty obvious to put in the CPAL as a known field. But let's say that you have another feature like ADDC that's proprietary. So the beauty of CPER is that you can put proprietary information in and you can make it super rich and do cool things with it. So CPAL should be complementary. I think it's fine if we say we have some common actions and there's a way to see that you're asking for something standard, but heaven forbid we prevent the suppliers from adding value-added features, right? We don't want to inhibit innovation. So, but this is a message. So you sent a message saying I'm sick. The analyzer said do something about it. We evaluate that do something to say, do we really want to do something? And when we say yes, we do, then we send the message back. But the BMC doesn't know what this message says. What it does is it says, I know who this goes to because it has the envelope. It has the CPAL envelope that routes it, but it sends the message to the GPU. And what we've done is we've created a pipeline for the analyzer from the vendor to communicate a message back to their silicon.
Yeah, I think, Drew, that makes all perfect sense. What I'm trying to communicate is a simple action could be swap the component, okay, or reset the machine.
Oh, sure. And like
right?
not like
shuffle,
CPU.
or shuffle the CPU, or shuffle the components, okay?
Absolutely.
Right, so those actions doesn't have to go back. The green arrow doesn't have to feed back, right? It could be an action to the fleet management entity of the data center repair team to go and take the action.
Yeah, and I think like sometimes we call it dance also for shuffle, but yeah, absolutely. And the repair. So and I was distinguishing you. I agree with you. Yeah, I've learned my lesson. Repair action and RAS actions are separate. So I hear you
Thank
and
you.
agree. I agree with you. And so
Anil
the
pointing
one.
out, yeah, I think what Anil is pointing out is that the CPAL needs a field to indicate a standard field, to indicate whether this is a RAS action that's going to happen automatically or a repair action that needs to get routed to like someone to look at. Right.
And the thing, and here's what I would do. Let me just make I'm going to propose a kind of I had this on another drawing and I left it off, but he's absolutely right. There's also repair, automation, right? That like schedules repairs and stuff, and everyone has it, right? You have something that says, oh, I've got to go fix something, and so the CPAL would also potentially come from, and I'll clean it up later, but you also have kind of an arrow here, and I completely agree with you, Anil. That is missing. I don't say it goes back to the machine because I don't think it does. I think it goes to tooling that gets a robot or a person to walk out to the machine with a spare part and do something physically to manipulate it. Where the message back to the RAS API is kind of a software automated response, self-repair response.
Right.
So Drew,
so good. That's a good catch.
Drew, in your example for the PPR versus the ADDC, would they both follow this same green CPAL arrow flow?
Yeah.
Okay.
And like if let's say that AMD is brilliant and they come up with the magic thing that can solve PCI signal integrity problems and make us have awesome PCIe links if we turn this feature on, but it uses more power, so we don't use it all the time. They could encode that in their error logging that they were seeing PCI errors that might help, and I mean, maybe we don't want to do that for runtime. Maybe they'd automate it, but they could make up some wild new feature. And as long as the error log has enough information to figure that out, you can send a message back. And I think we want to promote that, because here's the deal. We only have a limited number of self-repair actions today. And one of the reasons that's the case is that it's stinking hard to do, and nobody knows when to use the parts, and the pipeline's not standard, and the bits you have to twiddle in every chip are completely different for twiddling. And so what happens is people adopt their favorite RAS feature and neglect the other 80%, 90% of them. But by making the standard pipeline, what we're saying is, you can send your magic data, you can put it in your analyzer, you can drive the RAS back in a very, very common way. And so I think what's going to happen is that as silicon becomes harder and harder to make reliable, actions like this are going to be more and more important. And so having this pipeline in place where we can send messages back to the silicon to do things will enable us to do this and actually take advantage of it. I mean, PPR is a no-brainer, but it's not used to its full capability because it's too hard to use.
Yeah, Drew, let me correct you on that. We're at that spot now where, we need these RAS features, and the discussions I have with the new product engineers, or they kind of nod their head and they say, yeah, this sounds good, but I don't have time to deal with it. Go away. I've got to meet my
I got to get my product out the door. Yes.
Yeah, right. Exactly. So we're there now.
Yeah. And so the whole point of this proposal is to make that a low friction thing, where we have something that can process these errors at scale. And so if these messages are partially not I wouldn't say opaque. Well, okay, let's say that we're in a trusted relationship. Right? I'm working very closely with Intel and AMD, and we have a pretty open relationship. I might have more visibility into the CPAL than some other people. But if they have proprietary features that they don't necessarily want to expose too broadly, let's say that it's a random Joe's Auto Shop that buys a server for their data center, or their shops, plural. Maybe they don't have a trusted relationship. They probably need some visibility into the CPAL, but maybe not the same. There may be a need to have some level of proprietary data going back to drive proprietary features. And I don't love it, but I don't want to prohibit it, because we want to explore what we can do.
So I think, Drew, I think you're slowly defining the fields that are in the CPAL. There's the target, who you're sending it to, which could be simple, the BMC, and it applies some verb. So you're going to send a verb, what action you want done, some nouns, what you're doing it to, some metadata that says who it's from, and timestamps, and cross references and things like that. And your target could be the hardware standard OpenBMC, or it could be some proprietary software in that system that understands that the verb is a special verb for AMD because it's AMD system, versus a common one we would all use, like Anil is saying, reset or restart or something like that.
Well, and here's what I would say.
These actions are being defined as a part of RAS API initiative, right? This is part of that strategy.
Yeah. I think so. That makes sense. I guess here's what I would say, though, is the RAS actions are going to be where there's a lot of innovation. But when it comes to repairs, you can only do so many things. And like Anil had the right list, right? You can only replace a part or reseat it, or you can shuffle or dance it. There's not much else you can do.
Online repairs. So the online repairs give you a lot of opportunities. And what you might call a repair could be just telling the operating system, retire that page. Do you
That's a
consider that
RAS
repair?
action. So I want to distinguish a repair action is what a human does, and a RAS. That was why I was saying I agree with Anil now. A RAS, we're calling that a repair action. A repair action is, what a person does, or a robot, physically manipulating the system.
But Drew, Dean's bringing up a point, and it's a good one. I don't think that I understand your classification. I don't think it's complete, right? So as an example, right, one action would be, please move this to the repair pool and run this, test workload on it, right? Or run this self-diagnostic on it. That is not run. That is not run by a human, right? You can do that all automatically, but it is not run by the component. It is run by the data center control. So I think I think the way you want to think about it is exactly the way Dean said, right? There's like nouns and verbs and targets, right? And one target could be, the data center control plane, which is the BMC is an extension of that, right? And it can do a set of things. The component can do a different set of things, and maybe the same set of things, right? Then maybe there's some overlap there, right? But just think about it like I don't think the salient distinction is human versus automated. Well, I think that's one salient distinction, right?
Well, it is salient to a degree. Believe me, we care about it for our automation.
No, I get it, but I think like if you send something to the data center control plane, it could then be automatic or manual, right?
A PPR is a repair, right?
Well, so again, Dean is Drew is trying to differentiate, right? So, but I think the way you said it is right? Like you send this to at least multiple different targets. You can send it back to the component if there's an automatic thing that the component can do to heal itself, right? Drew is calling that a RAS action. You can send it to the data center control plane if the component can't do anything about it, but the component recommends that the data center do something about it. That could be automatic, like a reboot or run a self-diagnostic or whatever, or it could be manual, right? So
it sounds like we agree in the concepts, just the terminology we have to.
And Dean, now that Vilas has explained your point, Dean, you're right. I buy what you're saying. What I want to do though is just think of like from my perspective, for me to sell this to people inside Microsoft, what I've got to do is say, hey, look, we will describe what the humans need to do in the clearest possible terms, and it will be unambiguous, and you can automate it. So there is that requirement, but what you're saying makes perfect sense in that, well, if I might want to pull the part out and run additional testing, that makes, I totally agree.
Drew, I got one more for you because I have to drop.
Dean.
Okay.
Tigger. So is Tigger a special name, or do you have to wear a costume to do that action? C and D,
Trigger.
2C and 2C.
Oh, this is Vila, or Anil typed it, but I'm sure you meant trigger, right?
Yeah.
Thank you. You made my day.
Drew, so maybe I think this 1E additional debug, if, as Vilas pointed out, this can be done kind of in the control plane, doesn't really require human intervention. Maybe it should be a third category of kind of offline electronic debug. So no humans are required at that point.
So, I mean, just to be clear, right? Repair action in general are human oriented, but doesn't have to be. Okay, we have something called auto repair, which is fully automated.
Yeah, and I guess I do also want to make a point, and we should factor this. And I think this is, I guess that was Charlie, right? Like it could be, hey, please go get this additional information, right? So simple example, I think AMD and Intel both have some version of a crash dump, right? So maybe you get something, and then maybe there's a crash dump level 2, right? So the first crash dump, the action is go get a crash dump level 2 from this thing, right?
So
that targets them. Yeah.
We were talking about this last hour with JT on your team, and we told him to go see you, but we're calling some of those debug dumps, but maybe there's a crash dump.
Whatever,
maybe
whatever the name is, right? I'm just saying,
there'll be a continuum, there'll be a spectrum of them.
Yeah. But I think the main thing, though, right, and that this has to encompass is that's targeted towards the data center control plane to go use a component feature, right? So,
Yeah, Vila. So my question kind of is around if we have to go into this data center control plane, should that be its own category? Because that's kind of then a different flow in terms of diagnosing, debugging, and then deciding, you know what? We can fix this, put it back into operation, or nope, humans got to come in and pull it in and send it. Yeah.
I mean, I think very strongly, Charlie, that we should have a single data structure, the CPAL, that has all of this stuff in it. And then there's standard fields that, when the CPAL comes out, the data center policy engine kind of looks at it, parses a handful of the standard fields and says, oh, I got to go route this way. I got to go route this that way.
Well,
or I
well,
got
it's
to,
two things. It has
whatever.
to do things. It says, I know what this is and I want
Yep.
to do it, and here's how I route it. Yeah.
That's right. Yeah.
It's along those lines.
So part of the problem, though, is that we have defined repair action and RAS action as differently. If we just get rid of those and say, hey, you know what? RAS action, repair action, those are synonymous.
Yep.
Don't worry about those. It's these A, B, C, D, E, F, Gs that we're really talking about.
Yeah,
Well,
I think it's a target. It's the type, if it's an automatic or manual action, what is the recommended action? Like that there's a bunch of things.
Yeah,
Well,
I mean,
Charlie,
this is a starting point, right?
Yep.
Let's talk about it. Yeah, I agree. But
sorry guys, I have to do this every time because it's such a passionate group, bunch of people. 5 minutes over. I want to make a couple of comments too, but I'll hold back. Vijan, you just came off on your camera. Do you want to make the last comment before we wind up?
I was biting my tongue since I did a startup that did this, but so I will say, I think you guys are on the right track. I just be aware that the future of this is not human, right? So because the frequency of, as scale increases and complexity increases, then it becomes increasingly difficult for humans to manage things one by one. So there probably is a different flow for this than kind of what I call a closed loop scenario.
Well, and that's why one of the reasons I mentioned robots and action, like physical interactions with hardware. So I think.
By the way, there is one action is reset the machine by pressing a button, and guess what? There is an initiative to have a robot going in the data center, literally pressing the machine, pressing the button.
Oh yeah.
Oh, for the love of everything good, we can't do that remotely. God.
Pretty soon we'll be having drones flying in the data center.
But it fires like a Nerf bullet.
Exactly. No, just optical patterns. We don't need physical contact.
But I have seen initiatives where they have robots actually pulling the thing out, pulling a part out, and putting it back in. Now, it'll be the day when it's a CPU with the bajillion delicate pins. But
see, Drew, what you did, you made everyone dream.
This is great.
Especially if you think about this whole liquid cooling kind of infrastructure where safety hazards are pretty.
Oh, that's a really good point.
Right. So and Bijan, you're right. I mean, that's the direction we want to go, and that's why I think this defining this actionable automation, right, is very useful.
Yes.
So that something can be done automatically within the machine, something where we need some external entity, but doesn't have to be human. So what would that be, right?
Yeah,
You're right. And I think RAS actions will be defined as RAS API, and the other repair actions most of the times would be, I think, proprietary fleet manager or fleet admin defined, and all of this would be. Most of this would be optional, I'd say. I mean, recommended, right?
But Yogesh, I think that like in terms of hyperscalers, there are just a limited number of actions here. We want to call it out unambiguously in a standard way for simple things like reset the machine or reseat it. I think Anil's on the right track, right? We need
but that could be a policy, right? Some guy may want to spend cycles and time on reseating, and some guy may want to say, let's just replace and send it to evaluation.
Oh, I agree. Here's the way it would work though: is like let's say you say reseat the CPU, and we're like, nope, we're replacing it because that hadn't worked. Yeah. So I mean, we need a recommendation, but we may supersede it.
Yeah. So there is another step goes in after the CPAL. Okay. So CPAL provides a action. Now, really, that action is taken. That is actually another entity modulates that, which is we can call the data center policy. And I think Drew, you kind of you were drawing that as a policy there, right?
But wouldn't that be the response to the CPAL? Like that's basically you do want a response once you ask to do an action, right? So why would you need another entity to do that? The entity that you send the CPAL to should respond with completion or
exactly.
The reason we need that is let's say through the automation, right? analysis output or action is reset the machine. Okay, but let's say the machine has already been reset multiple times, and there's already known issue that the data center is aware of, data center fleet manager, right?
Yeah.
Then they can modulate that further and say, you know what, I don't want to reset it. Now I know what is the next action need to be taken. So there's a cascade of intelligence built in.
Exactly.
And then
we can do AI on this. Our
right.
fleet policy maybe run AI on, or it might be, hey, if it's this really high profile customer that we're trying to keep super happy, we repair it immediately. And if it's
Correct.
this other customer that can tolerate failures left and right, we don't care. So
Yeah.
so that's where we just need the room as a hyperscaler to make the ultimate decision. But we need a recommendation. We take
Correct.
the recommendation, and then based on the recommendation, we decide what ultimate action we want to take.
So wouldn't that, I would think that that would kind of be in the analyzer itself, where the analyzer says, hey, I just issued a command to reset this machine yesterday, and now I'm coming back with the same analysis. Clearly the reset's not working. Take the machine offline.
If the analyzer can be that smart, that is awesome. But
Okay.
but like Anil said, we'll have other factors that the hyperscaler knows about that are particular to that hyperscaler, and the analyzer may not know about.
Okay, but wouldn't that be something the hyperscaler would put back into the analyzer? I mean, if we're talking about automation here.
Yeah, absolutely. I think you're right, Charlie. Eventually, once that the knowledge base is what's called proven, right? That it is working and we are mitigating the issue across the fleet, then we roll back into the analyzer itself.
Well,
okay.
Yeah, if it's standard. I mean, like
Yeah.
if it's like based on my customers and which customer is more sensitive, forget it. That's that's a fleet policy. But yeah,
Okay,
if Exxon learns that this error means this and teaches that to the silicon vendor, then we want the silicon vendor to take all the lessons they're learning from all the people using their analyzer, put it back into the analyzer, and regularly drop new analyzers to us, so that we continuously improve. That is
kind of the learning,
that is
the
the
learning
dream.
flow.
That's the heart of the dream, actually.
By the way, that's where our team expertise lies, where we keep incorporating these automation brain, right, to keep improving, because the fleet is such a heterogeneous and such a large that there's no single solution for every error, every failure, right? So we need to iteratively keep analyzing, updating, building the intelligence. So that's why this is very useful to standardize at least some of the areas. Today, most of the stuff is all proprietary, and it's very complex, very difficult to maintain that. So this initiative will help us standardize some part of it. We can't eliminate, we can't completely replace what we have today with this approach, right? We still have to use all the intelligence that we have.
But I'll be blunt. I want Microsoft to benefit from the lessons that Meta's learning with our silicon suppliers.
And, absolutely.
And you want to benefit from the lessons we learn, and that's great, because if we have healthy silicon, it's just good for all of us. So
let's talk offline on that.
All right, guys. So shall we call it a meeting today and meet next week? If not, we have to sponsor happy hour for us.
Yeah, I think we lost VLOS, but hey, thanks. This was a great discussion.
Yeah.
And I think what we're doing, like, this is a huge deal. That's why I'm saying we need to couch this in terms that our VPs understand what a big deal this is and how much this is going to help all of us do better together.
Yeah, Drew, and I think to the point of teaching one another, both from the component as well as the system and the software side. One of the things that occurs to me in working in the reliability physics area for the past couple of years is we are working with very, very, very sparse data and trying to figure out what's going on versus other areas of electrical engineering where you get way too much data.
Yeah.
You get more data than you can analyze. So I think if we all team together across the component and system groups and share what small information we've got, we can all learn much quicker.
Yes, and if the system captures the right data up front,
Yeah,
Intel
exactly.
captures it. Then you get the same data, I get the same data, we give it
Yeah.
both give it to Intel, and Intel makes its bed, right? If it does a good job of logging the data, it can figure out what's going on and make its products better. And if it doesn't,
that's a
then
good point, capturing the right data, because right now I'm getting tons of data from my systems folks saying, we've got ECC errors, we've got problems with our memory. And I'll ask, so which address, which link, and don't have that data. We don't capture that. Which bit? We don't capture that. So we're getting a lot of error data, but not the right or not sufficient data.
Yeah. Yeah. Awesome. Well, we are way over, but I appreciate the passion. That's what I love about this group. Those are one of the things I look forward to every Friday. Thank you for being with us, Yogesh. You got a tough crowd.
Have a good weekend. Enjoy it equally, and I added that CPER store to the diagram. We can talk about it next week.
Oh, cool. Yeah. Yeah, that makes sense. Okay, we'll have to figure out. There's probably the CPER store ahead of the parser.
Yeah, I know we can work on that, but there's some CPER store that
Yeah.
that provides the retrieval of history for time series.
Well,
what have
yeah.
you.
Yeah, and here I'm showing it with previous CPERs.
Right.
And so I just haven't combined them all in one place. But yes.
Yeah, and that's what I was thinking, that hey, as long as we can provide some notional bundle reference of what CPERs were sent to the analyzer for creating this action, that's all we really need. We really need to bulk up the record CPAL itself with a lot of records, right? We just need to provide a reference to what was used, and then if it comes to the point that, okay, we need to, go back and see what was used for this analysis, that reference can come handy, and then those CPERs.
I mean, it could just be a note in the output. Yeah. I don't know. I don't know the answer. Let's explore that. That sounds great.
Okay, then let's talk. Have a good weekend, guys. Let's talk next week again.
Sounds good. Thanks, everybody.
Thank you.
Bye.
Bye.
Yeah.